Mr. G's class, online learning, school closure, let's go. This is Mr. G's class. I said it's Mr. G's class. I said it's Mr. G's class. I'm online. This is Mr. G's class. I said it's Mr. G's class. This is Mr. G's class. 1, 2. I'm online. Yeah, I'm online. Yeah. Grab your pencil and pen. Now let's begin. Got the lessons online, time to learn again. Try your best, complete the work, the best that you can. As I come up with great original lesson plans, I'm keeping you busy like bees in a hive. Lesson plans on the hard drive, kicking it live. We're gonna do math and English most of the time, but trust me, we'll have fun like me saying this rhyme. Good morning, everybody. Welcome to another day of online learning. Today, what we're going to be doing is we're going to be using tree diagrams to calculate the number of possible outcomes of an event if it's repeated several times. So what I'm going to do is we're going to start off with some very basic ones. For instance, if you flipped a coin. So if you flipped a coin, the very first or the only two possibilities you can have when you flip a coin are heads and tails. Okay, so because there's only two sides to a coin, the only possibilities you can actually get when you flip a coin is heads or tails. Both have an even chance or a 1 out of 2 chance to flip either side of the coin. Now, that's easy to get that kind of fraction, but what we're going to be dealing with are fractions when you conduct an experiment and have to do the experiment more than once. For example, flipping a coin twice. So if you wanted to flip a coin twice, you want to see all the possible combinations that can occur when you do this. So let's say you have a coin. The very first flip that you have, you can either pick heads, make sure this is in focus, heads, or you can get tails. Those are your only two outcomes. Now, if you flipped heads the first time and you're flipping again, all right, you have another two possibilities. So on the second flip, after you flipped heads the first time, you can now flip either heads or tails. Oops, meant to put a T there. Okay. Now, the same thing happens on the side with the tails. So if you flip tails the first time, on the second flip, you can flip either heads or tails. So this tree diagram shows all the possible outcomes that you can get when you flip a coin twice. So all these ones down here represent all the different possible outcomes. You can flip first heads, for example, heads then heads, or you could get heads then tails. You could get tails then heads or tails then tails. Now, if I had to ask you the possibility or the probability, what is the probability of flipping heads and then tails? Okay, you would have to circle that event. So heads, let me make this a bit bigger. So we have heads to tails. All right, so the condition is, well, what are the chances of flipping first heads and then tails? Well, that's it. That's the one branch of the tree that you would follow for this outcome. And since there are 4 possible outcomes, and this is the one we want, our fraction for flipping heads then tails would be 1/4 or 1/4. Okay, and that's because there's you have to follow that one path, heads then tails. Okay, all right, so that's a 1/4 chance of flipping heads then tails. What if I asked you, well, what's the probability of flipping tails and then tails again? All right, so that would be this one right here. And again, since there are 4 possible outcomes below and this is the one that you want, that would be a 1 in 4 chance. It's hard to manipulate this computer and camera and everything at the same time. So this is a 1/4 chance. Now, if I asked you, what's the probability of flipping tails, then either heads or tails, okay, then this branch would work as well as this one, because the condition is flipping tails first, then either heads or tails. So those two branches work. So you would have a 2 out of 4 chance in flipping this, or meeting that criteria. All right, I'm going to use another example here. You're going to get something similar to this in the homework today. Let's deal with clothing. So we could have tops and bottoms. So for a top, let's have a t-shirt, a sweater, and what else? Let's put a coat. All right, so we have 3 items we can pick from for a top. We have a t-shirt, a sweater, and a coat. And let's pick 2 bottoms. All right, let's pick pants, and let's say shorts. All right, let's try that again. So for tops, you could have a t-shirt, a sweater, or a coat. For a bottom, you could have pants or shorts. So what I'm asking you is, well, how many possible combinations are there with all these different kinds of clothing? Okay, and then we'll get into some probabilities of what people might wear. All right, so to find all the possible combinations, the first thing you can wear, all right, are your tops. So you're going to have either a t-shirt, you can wear a sweater, or a coat. Those are your 3 options. Okay, you have to wear one of those 3. All right, now for bottoms, you have 2 choices. So for this one, you would have 2 branches going out. All right, so you could have pants or shorts. All right, so we would draw the same tree over and over again. Let me see if I can get this working here. Oh, oops. Oh no. Let me rewind here. Copy, paste. All right. Now, with all these trees here, you can see all the possible outcomes. You could have a t-shirt with pants, a t-shirt with shorts, a sweater with pants, a sweater with shorts, a coat with pants, or a coat with shorts. So right down below here, let me switch a color here. These are all the possible outcomes. So you have 6 possible outfits you could wear with all these different combos or combinations. So if I asked you, well, what's the probability of wearing a sweater with pants? You would have to circle this right here. That's the only condition here. So you have to wear a sweater with pants. So since there are 6 possible outcomes and only one of them meet the criteria, you would have a 1 in 6 chance of wearing that. That's the probability of wearing that. All right. Now, what about another probability? How about wearing a coat with either pants or shorts? So 2 of those branches meet the criteria. So here's your coat with the pants, and here's your coat with the shorts. So right now, those are 2 circled out of the possible 6. So that would be 2 out of 6. So you would have a 2 in 6 chance of wearing that if you're just wearing clothes randomly. All right. Now, what if I said, well, what are the chances of wearing either a t-shirt or a sweater with pants? So those are the conditions: a t-shirt or a sweater with pants. So here's your t-shirt with pants. Here's your sweater with pants. And those are the only 2 conditions that meet the criteria. So when we look at that, that again would be 2 out of 6, because 2 of them meet the criteria. All right, let's do another example. So in this hat of mine, I don't know if you can see that. Not really. Whoops. I have a bunch of cubes. Let me get them out here so you can see them. I don't know if you can see that. It's difficult to see. Let me see if I can focus this here. You can't really see. But anyways, I have 2 reds, a yellow, and a green. Okay? So I have a red block, another red block. I have a, let me focus this one, a yellow and a green. So there are 4 blocks that I'm going to put into a hat, for example. And if I shook that up and I randomly drew one cube at a time, but I did this twice, I want to see what possible combinations I could have when drawing two cubes after I replace the cube, the first pick the first time, back into the hat. You'll see what I mean. So these are the different kinds of cubes we have here: a red, a yellow, and a green. So on your first pick, you can pick, I'm going to just change this to black. You can pick a red, you can pick another red, you could pick a yellow, or you can pick a green. Now after that's picked, I'm gonna put the cube back into the hat and randomly pick another one. So let's say you picked red the first time, and then you put it back into the hat. Now on your second draw, you're gonna have another 4 chances, because there are 4 different kinds of cubes that you can draw from the hat. So you can pick another red, you can pick a yellow, and a green. Okay, let me explain this one more time. So if I pick that red one, and then I put it back into the hat, on my second draw, after I take it out, I can re-pick that one. So I can get another red, well, this red, another red, a yellow, and a green. Now, what if I pick that other one and returned it? Well, it would be the same thing. I would have another red, a yellow, and a green. Now let's say I picked the yellow the first time. On the second pick, I can pick the red, a yellow, and a green. And on the last one, if I pick a green, I can pick another red, yellow, and the green again. This is because I replaced the block or the cube after the first pick. It's called probability with replacement. So how many possible combinations are there? Let me separate this one so it's a little bit neater. Okay, so these are all the possible combinations you can get when you are, let me focus this again, having some focusing problems here. These are all the possible combinations you can get when you are picking 2 cubes out of a hat randomly and replacing the first cube after you've taken it out of the hat. So let's run through some probabilities here. What if I asked you, well, first we got to see how many total possibilities or combinations are possible. So if you look at the bottom here and you count all of these, okay, 4 times 4 equals 16. So there are 16 possible combinations here. All right, you could have picked red, yellow, red, green, red, yellow, red, green, yellow, yellow, green, red, green, yellow, green. Those are all the possible combinations. So what if I asked you, well, what's the possibility of first picking a red and then a yellow? So you would have to circle all the ones that meet that criteria. Okay, so first a red and then a yellow. That's the criteria. First red and then yellow. But look over here. We have another one here. So I can pick this red and this yellow. All right, so if the criteria is the first pick has to be red and then the second pick has to be yellow, those are the only 2 possible combinations. So you would have a 2 out of 16 chance of first drawing a red out of a hat and then a yellow if you just randomly picked two blocks after replacing the first one. All right, what if I asked you, how about red than any other color? Okay, so then what would happen is you would pick this red and then all of these. Okay, and then you could also pick this red and then all of these. So red and then any other color, if I asked you what that probability would be 8 out of 16. All right. Let's do another one. What is the probability of drawing yellow and then red? Okay, so there's an order here. So let's take a look. So we have yellow, and then red. But look at this, we have another one, yellow, then red. The order is important here because I said what's the probability of drawing first yellow and then red? Okay, well those are the only two that meet the criteria, so that would be 2 out of 16. Now, what if I asked you, what are the chances of drawing a yellow and a green? All right, no particular order, yellow and green. So what we would have to do is we would have to find all the branches that would have both yellow and green in them in no particular order. So for example, here's one, yellow and green. That would match. Now, because it doesn't matter what order you have here, you could also go green and then yellow. So the chances of picking a yellow and then a green, or a green then a yellow in no particular order would be 2 out of 16. All right, and that's because there's no particular order here. All right, let's do one last example. How about picking a green and then green again? What are the chances? Okay, so going to green, well, here's my green, and then picking green again. So it's very unlikely I'd be able to do that. So that's a 1 in 16 chance, because that one branch meets the criteria, green then green, okay? And then there are a total of 16 choices here, or 16 combos. All right. Hope that helps for today's homework. I'll see you guys later. Another icon beat. Mr. G's class, online learning, school closure. Let's go. This is Mr. G's class.